Part 2 of lesson 2.7 is going to be all about linear pairs and vertical angles. So if you don't remember what those are, a linear pair is two angles that are both adjacent and supplementary. So if you don't remember, adjacent means that they are next to each other. So you can see these two angles share this vertex, and they share this line right here. So that means that they're a linear pair. So linear pairs are always going to be supplementary because they add up to a straight line. You can see when we put angles 1 and 2 together, we get this straight line right here. And a straight line is 180 degrees. So if you think about having a point here and a point here, and if we were to rotate around, that would be a rotation of 180 degrees around this vertex here. All right, so the angles, if they are supplementary, that means they add up to 180. Theorem 2.6, this is called the vertical angles congruence theorem. And I'm going to use the word congruent, the symbol congruent instead of writing out the word. And this says exactly what you would think it would by the name. It says that all vertical angles are congruent to each other. So in this picture on the right, we've got angles 1, 2, 3, and 4. Angles 1 and 3 are vertical angles. So vertical angles are the angles that are across from each other in the intersection of lines. So angle 1 we could mark congruent to angle 3. Now there's two pairs of vertical angles in any set of intersecting lines. So there's also this pair, 2 and 4. That's also a pair of vertical angles, and they are also congruent. So we can say that angle 2 is congruent to angle 4, and that angle 1 is congruent to angle 3. Now let's prove that. Let's prove that that is true. So we're going to have to use linear pairs in order to do this. So in this proof, we're going to use angles 5, 6, and 7. We don't need this angle up here. That one doesn't matter. All we need is those three. So basically what we're going to do in this proof is we're going to say that since 5 and 6 are a linear pair, they are supplementary. And since 6 and 7 are a linear pair, they are supplementary. So that means that 5 is supplementary to 6 and that 7 is supplementary to 6. Well, if two angles are supplementary to the same angle, then they must be congruent to each other. So that would mean that 5 and 7 are congruent to each other. This is by the congruent supplements theorem. That's what we looked at in the last video. So let's go through the proof. We start with the fact that 5 and 7 are vertical angles. That's given to us. We do have the statement right there, but we can also see it just by looking at the picture. When you're given a picture in a proof, if there's anything on the picture that is obviously true, then you can use that as part of your proof. So, even if we weren't given that 5 and 7 are vertical angles, we can see on the picture that they indeed are vertical angles, so we could use that in the proof even if it wasn't handed to us in the given. But the reason we know that is, of course, because it is given to us. Then step 2, it says 5 and 6 are a linear pair, and that 6 and 7 are a linear pair. Well, like I was just talking about, we can look at that on the picture. We can see that that is true in that diagram. So since 5 and 6 are adjacent and they add up to a straight line, if you put them together, you get this straight line right here. Same thing with 6 and 7, you get this straight line if you put them together. That means that they are going to be a linear pair. And if they're a linear pair, that means that they're supplementary. So we just talked about that up here. Linear pair postulate says that if two angles are a linear pair, then they are supplementary. That's part of what it means to be a linear pair. So we can say that this is true by the linear pair postulate. And I'm going to abbreviate postulate as just P-O-S-T. Then we can get from the fact that they're supplementary to the same angle to the fact that 5 and 7 are congruent to each other by the congruent supplements theorem, which again we proved in the last video. So here we have that 5 is supplementary to 6 and that 7 is supplementary to 6. So that must mean then that 5 and 7 are congruent to each other because they're both supplementary to the same angle. So this is the congruent supplements theorem. Let's go on to example 2. So in example 2, we've got 4 angles around an intersection here. It tells us that the measure of angle 1 is 112 degrees. So let's find the other 3. Well, first one is an easy one. Angle 3 we can say is 112 degrees because these are vertical angles, so they must be the same. We just proved that that is true. So then we can look at angles 4 and 2. Now these are vertical as well, so if we find one of them, then we found both of them. So we just need to find one of them. And to find one of them, we can use the linear pair postulate. So we could take any pair of these next to each other. I'll just take 1 and 4. So 1 and 4 add up to this line right here. You can see that they are adjacent because they share that line right there and they share this vertex. But you can see the most important thing here is that they add up to a straight line. So they are supplementary, so they add up to 180 degrees. So we can take 180, subtract 112 from it, and we will get 68. So this angle has got to be 68 degrees, which means then that angle 2 must also be 68 degrees because they are vertical to each other. Now, one side note, you can see that this picture is not exactly accurate, and that's fine. So often in geometry, our pictures will not be entirely accurate to what the actual numbers are saying, and that's fine. And that's part of that is that we don't always know what they are. So sometimes we'll have variables in there, we won't exactly know what the angles are. So the picture is really just to kind of give you a visual understanding of what's going on, and not necessarily meant to be perfectly accurate in terms of the angle measures being what they're actually written here. Because if we took a protractor and measured these 4 angles, they would not match up with the numbers that we have here, and that's fine. So the picture is just to give you a visual understanding of where things are in relation to each other. All right, let's move on to part B. So we've got all the same angles 1, 2, 3, and 4. And it says if the measure of angle 2 is 67 degrees, so that's this one here is 67, find the other measures. Well, the first easy one is go across from that. Vertical angles are always congruent. And then same exact argument as before. We've got linear pairs here. So say 4 and 1 together, that makes a linear pair. So they've got to add up to 180 degrees. So if we take 180 and subtract 67, we will get 113. So that means that one's got to be 113. Vertical to that is angle 3, so this one's got to be 113 as well. On the back side, let's look at this. So we've got 4 different angles, and now we've infused some algebra in here. So these aren't just straight numbers. We've got some variables. So the top has a y in it, the right side has an x in it, the bottom has a y in it, and the left side has an x in it. So what we're going to try to do here in order to find the measures of all 4 of these angles is that we're going to need to find a variable first. So, if we want to know what this angle here is, we need to know what x is. So let's see if we can find a way to solve for x. Well, if we were to try to combine, say, the 6 times x plus 2 with the 18y minus 18, say if we were to try to come up with an equation that would have those 2 in it, say maybe if we were to add them up and set it equal to 180, because these are a linear pair, so that means they're supplementary. So we could say that 6 times x plus 2 plus 18y minus 18 would be 180. That's true. But that equation would not be helpful to us because it has both an x and a y in it, so we can't solve that. So we've got to look at, well, let's see, this one has an x in it, and this one has an x in it. Neither of those have y's in them. And so if we do something with those 2, then we could actually solve that equation for x. Well, those 2 angles that I've underlined there, those are vertical angles. Vertical angles are always congruent to each other. So we can say that 6 times the quantity x plus 2 must be equal to 10 times x minus 4. And then if we solve this equation, we can get a number for x, and then we can plug it back in to try to find the angle measures. So on the left side, we need to use the distributive property. 6 times x is 6x, and 6 times 2 is 12. Copy down the right side. Now we've got an equation that has variables on both sides, and it has numbers on both sides. Let's try to get everything with a variable on one side and everything with without a variable onto the other side. So let's say subtract 6x from both sides. That goes away, and we're left with 10x minus 6x is 4x on the right side. Copy down the rest. Now we've got everything with a variable condensed right here. So let's try to get everything without a variable to the other side. And we can do that by adding 4 to both sides. Then 4x is equal to 16, and we can solve for x by dividing by 4. So then x is equal to 4. Again, that's not the answer. We're on our way to the answer, but we're not done yet. So in order to find the angle measures, we need to take this x value and plug it back into one of these equations. So let's take, say, 6 times, instead of x, we'll write 4, because that's what we found x equals. So that's 6 times, and 4 plus 2 is 6, which is 36. So that means that this angle here is 36 degrees. Well, vertical to that is this angle here, so we could say that this is 36 degrees. Or we could have taken our x value of 4 and plugged it in here. 10 times 4 is 40, minus 4 is 36, that'd be just fine. And now for the other two angles, well, we could set up an equation just like we did. We could say that 18y minus 18 is equal to 16y, and then solve that equation, find y, plug it in, and then get the angle measures. That would work. We would get the right answer. But that's more work than we need to do. So we already know that these two angles are 36 degrees. And we know that, say, if we look at these two angles, this one and this one, these are a linear pair. They add up to this straight line here. And so they've got to be supplementary. They've got to add up to 180. So we could just take 180 and subtract 36, and we would get 144. So this angle must be 144. And then since this one is vertical to that, it's also got to be 144. So we don't even need to find y for this. If you look in the instructions, it didn't say find x and y, it just said find the angle measures. So we can do that without finding both of the variables. Now we of course do need to find one of the variables, but we don't actually need to find both here. All right, part B. So it might be tempting to try to do this one the same way as we did before. So we might say something like 10y is equal to 7x plus 4. Let's give that a try. So 10y is equal to 7x plus 4. Well, now if we look at that equation, we've got both an x and a y in that equation. Well, we can't solve that equation. There's no way we can get something like x equals 5. We can't do that, not with two variables in the same equation. So we've got to find a different way to combine these. So this one has a y in it. Well, this one also has a y in it. So if we try to combine these two together, then we would be able to get an equation that we can solve. So while this equation is true, it's not helpful to us. So we're just going to cross it off. Again, it is true. It absolutely is true, but we can't get anywhere with it. So let's use these two here. Well, that's a linear pair. Those two add up to this straight line here, which means they've got to be supplementary. So what we could say then is we could say that 3y plus 11 plus 10y must be equal to 180 degrees. So if we add them together, we should get 180. Now we've got like terms here, 3y and 10y, we can combine to get 13y. And then solve this, so we want to try to get the variable by itself. We could subtract 11 from both sides. And then divide by 13. So we get y equals 169 divided by 13 is 13. Again, that's not the answer. We're on our way to the answer. So we weren't asked to find x and y, we were asked to find the angle measures. So let's take this y value of 13, plug it back in here. So 10 times y, that's 10 times 13, is 130. The angle vertical to that is also going to be 130. And then we could find the other two just by remembering that these are a linear pair. So if this one's 130, that leaves 50 for this one because they've got to add up to 180. Then this one over here is vertical to the 50-degree angle, so it's 50 degrees as well. So again, we don't actually need to find x here. You could, if you wanted to, you could say that 7x plus 4 plus 4x minus 22 is equal to 180. Go through and solve that equation for x and plug it back in. You could do that. You would get the right answer, but again, we don't need to do that work. Once we find one of the angles, we can find all three of the other ones just by using the fact that we've got linear pairs and vertical angles.